Alright folks, so today in fact we are going to be talking about the greenhouse effect, and when we are referring to the greenhouse effect, we can see from the image on the screen it is associated with the sun transferring its energy, right, upon the earth. But it is in fact a bit more complicated and more complex than that. Alright, in this particular video I'd like to highlight certain key concepts. First and foremost, we like to define the greenhouse effect, as well as referring to the significance or the importance of it. All right. By extension, we'll be highlighting also the shortwave and longwave radiation and their impacts or their influence, right, upon the entire greenhouse effect. All right. And last but not least, we'll be also citing some examples with respect to greenhouse gases and also their sources. Let us begin quickly. Now, what is the greenhouse effect? Now, it is a process whereby solar energy enters the Earth's atmosphere, and in doing so, it is in fact absorbed by existing gases in the atmosphere. All right, these gases are what we call greenhouse gases, and since they absorb the energy from the sun, right, they tend to facilitate the warming effect of the planet. Now, let us bear in mind that it is, in fact, a natural process. All right, it is a naturally occurring process. However, in this day and age, human activities or anthropogenic activities are, in fact, very, very important. So, the greenhouse effect is a natural process, but it is in fact influenced or, in some instances, accelerated by human activities. Now, to continue, energy coming in from the sun can be subcategorized into radio waves, microwaves, infrared radiation or infrared energy. We have light, visible light. We also have UV radiation, X-rays, as well as gamma rays. All right. Now, students, the only one that we can see with our naked eye is in fact visible light. All right. As you can see, the colors of the rainbow here, Roy Jubiv, as we would have done in the past. But the one that we are referring specifically to is in fact infrared radiation. Now, infrared radiation can sometimes be termed as heat waves. Now, unless we have infrared goggles, right? We humans cannot simply observe infrared radiation with our bare eyes. All right. Animals can do so. For example, some snakes can they can detect rather, infrared radiation and heat or thermal signatures. All right, but that is associated with certain animals. No, now students, infrared radiation refers to heat energy or heat waves, which can simply be absorbed by bodies, all right, or objects within the environment. Okay, and this is actually very, very important. All right, so from the screen here, we are seeing the sun and we are also seeing the earth, which is bordered by the blue line. All right. Bear in mind for me, energy coming in from the sun contains what we call high frequency energy. Now, students, when I say high frequency energy, it simply means they have short wavelengths associated with energy coming in from the sun. All right. Bearing in mind for me that the energy from the sun is in fact very distinct. Now, in terms of understanding the frequency and also the wavelength, there is an inverse relationship between wavelength, which is what I'm showing you here, and frequency. Okay. Now, just to highlight again, high frequency, right, refers to energy. High frequency energy is in fact that energy which is in fact being emanated from the sun. All right, high frequency is in fact associated with short wavelengths. All right, what is the wavelength again? If you look on the screen carefully, you can simply see this red arrow, right, between two very distinctive crests. All right, these two areas here. This distance is in fact what we call the wavelength. And shortwave radiation or short wavelengths associated with energy which has high frequency enters the Earth's atmosphere from the sun. Now, given the fact that the Earth is actually very cold in comparison to the surface of the sun, all right, the energy dissipates. And this energy, if you realize, if you look at the screen here, this energy simply comes into contact with this is actually referring to the ground level. All right, the ground level. And the energy comes into contact with the Earth's atmosphere. All right, observe, of course, the wavelength increases. All right. All right. Now, students, this long wave radiation, right, also known as energy, which is basically dissipating into the environment, basically has lower frequency. All right. What does that mean? If it has lower frequency, it simply means that the energy dissipates and the energy level technically goes down, it depreciates. All right, so this is the overall movement of the energy coming into the Earth. The Earth's environment simply absorb a very large fraction of it. But look at what happens here. The surface of the ground level becomes heated up, all right, and the hot air rises. All right, if the hot air rises, technically, the energy would actually what? Tend to rise and radiate from the surface of the ground. And in doing so, it cannot expeditiously exit the Earth's atmosphere. As the energy rises, it cannot be allowed to efficiently exit the Earth's atmosphere, and there's a reason for that. All right, this particular line that I'm showing you here, the long wave radiation, having lower frequency, having lower energy, right, is in fact redirected back to Earth, even though it is rising or it is in fact attempting to exit. All right, look carefully on this particular image here. You can actually see the wavelength also increases further as the energy dissipates even more. All right, this energy, which simply is redirected back to Earth, all right, as you can see in the purple arrows coming back down from the blue line, that is technically highlighting uh, the inability, right, or the limited efficiency of long wave radiation from exiting Earth's atmosphere. And this contributes to a warming effect of the entire globe. All right, very little is allowed to escape. All right, very little exits the Earth's atmosphere, but a very large amount remains cushioned within the Earth's atmosphere itself. Keep that in mind for me, please. So just to reiterate very quickly, shortwave radiation, also known as high frequency energy, comes into the Earth from the sun. It is also termed to have short wavelengths. As it enters the Earth's atmosphere, all right, it becomes dissipated. All right, components of the atmosphere will tend to absorb some of this energy. For instance, the ground level. This dissipation will contribute to the development of long wavelengths, and the energy is said to be of lower frequency, which is termed largely as long wave radiation. When the energy simply rises off the surface of the ground, all right, we realize that the wavelengths associated with these are in fact significantly longer, and it cannot expeditiously exit the Earth's atmosphere. So keep that in mind for me, please. All right, and this contributes to the warming effect. All right, now highlighting the importance of the greenhouse effect. Let us just simply say that in the absence, in the absence of the greenhouse effect, the Earth would in fact be too cold to sustain life. I'll repeat that. In the absence of the greenhouse effect, the Earth would in fact be too cold to sustain life. So essentially what I'm saying is that the greenhouse effect is extremely important in terms of the continuity and the development and the progression of life in this particular planet. All right, because the warmth from the sun is in fact utilized by biological organisms, even well, all organisms as a matter of fact, from microorganisms all the way up to macroorganisms, micro to macro. All right, we should bear in mind that every single organism on the planet utilizes at some point energy. All right, energy, especially in this form, thermal energy. All right, which is utilized for a multitude of reasons. For instance, plants utilize thermal energy under the radiant sunshine as well to photosynthesize in terms of manufacturing their own food. Animals utilize thermal energy to maintain a healthy body temperature, which is in fact very, very important for their enzymatic activities within their gut, all right, as well as their level of reproductivity as well. Okay, we have to understand that our presence, our activities, human activities, for example, combustion of fossil fuels, deforestation and whatnot, are in fact major ways we can upset the ecosystem. Right? We'll talk about that just now in a couple of minutes. However, we should understand that the more greenhouse gases produced into the environment, although greenhouse gases are essential, right? But the more we produce into the environment, it would result in a negative effect upon the environment, primarily because these greenhouse gases would essentially absorb more warmth or more heat. Now, as indicated earlier, greenhouse gases are in fact naturally existing gases. Some of them are anthropogenically introduced, right, because of human activities. But these gases are more or less naturally existing in the environment, and they have a very significant role in terms of absorbing warmth or thermal energy. All right. Some basic examples of greenhouse gases include carbon dioxide, methane, nitrous oxide, sulfur dioxide, as well as water vapor. Let us begin with the first one. Now, carbon dioxide is in fact one of the most significant greenhouse gases in the world. All right, there are in fact numerous sources to which carbon dioxide can in fact be associated. We can simply cut down trees or deforest or engage in logging activities over a very vast area, and this essentially reduces the photosynthetic processes. Now, trees photosynthesize, and in doing so during the daytime, they take in a bulk of carbon dioxide. But in the absence of trees or the reduction of trees, more carbon dioxide actually spews into the atmosphere. All right, and the fact of the matter, it contributes to a larger concentration, which thereby absorb much more warmth. Okay, we also have combustion of fossil fuels, which is often associated with industrial activities. We also have respiration associated with both plants as well as people, animals, right? For example, we respire, plants also respire throughout the day as well. In addition to which, we also have unsustainable, right, agricultural practices such as slash and burn, where people simply burn large expanses of land. With respect to methane, right, methane is actually very significant because methane is produced is a product of digestion. All right, methane is in fact a product of digestion, as you can see on the screen. It is also a significant gas found in landfill sites because of disintegration of organic materials. In addition to this, we also have nitrous oxides, and nitrous oxides are largely associated with vehicular emissions. All right, for example, these concentrations are in fact very, very high, especially in those urban environments. Sulfur dioxide is also a very significant greenhouse gas. Yes, sulfur dioxide isn't produced naturally by volcanic eruptions, very, very large concentration are produced here. However, we must bear in mind over a continuous period, we must bear in mind that industrial emissions of sulfur dioxide because of the combustion of fossil fuels, right, is in fact very, very significant. Okay, last but not least, I would like to talk about water vapor. Water vapor is a naturally occurring gas which is associated with the hydrological cycle. All right, water vapor is very unique. It is moisture in a gaseous state or gaseous state, however you want to say it. Water vapor exists in the atmosphere. All right. Bear in mind, students, that this particular component, it is naturally occurring, but unlike sulfur dioxide, unlike nitrous oxide, unlike carbon dioxide, and unlike methane, water vapor is not a pollutant. The four previous greenhouse gases that I mentioned earlier, they are greenhouse gases, yes. But because of human increases and the explosion of these gases in high concentration in the atmosphere, they are categorized as pollutants as well. Water vapor is not considered or not regarded as a pollutant. All right. Bearing in mind, it's a bit of a note, a bit of an insight. There will be another video talking about global warming. The increase in concentration of these greenhouse gases and many others would contribute to more warmth being trapped within the earth, and that will undoubtedly result in an increase in the average temperatures around the world. So the accelerated version or the accelerated effect of a runaway greenhouse effect, all right, can be a major contributor to global warming. All right, so I hope this video is beneficial. Any questions, feel free to let me know. All right, students, you all keep good. Bye.